Okay, so today we are doing our notes for function notations and explaining this function notation and evaluating functions. So, first, what is function notation? So, function notation is taking the notation prior, which we had before, which was x and y equals 2x plus 4. So, when we get into more complicated things, sometimes we have to give these functions a name. Okay. So how we name them is we substitute the y for f of x. So this reads, I'm going to keep the part that stays the same in black. So instead of y, it becomes f of x. So this over here becomes f of x equals 2x plus 4. So again, you've probably heard me. This reads as f of x. We are naming the function. And the reason we do this is because sometimes when we're moving and working with multiple functions, each one has to have a name of what we're dealing with. So maybe one function is handling all of your schedules on A day, and then another function is handling your entire schedule on B day. Okay, so they were just naming them. This does not mean f times x. Okay, the function f of x depends on x. F is the name of the function. X is the input. Remember that Dixie, Roy. X was the input. F of x was the output. Okay, so again, your x is still your domain. It's still your input. It's still your x value. It's still your independent variable. The f of x is your range. It's your output. It's your y value. It's your dependent variable. And of course, letters other than F and X may be used, but F and X are going to be the most common. When we start naming them for different reasons, for different real world situations, is when we use different letters. Just like we did here. We always used X and Y until we started talking about things like the price of bananas, right? And then we would have whatever bananas and cost, so B and C or something like that. So F is, again, as I said before, F is the output, the Y value that corresponds with the input, the X value. So if we're given F of 3 equals 2, so my input value is 3. My output value, I'm going to go ahead and write this in a different color. I'm going to write it in green. I think my output is 2. So my ordered pair would be 3, comma, 2. So this next one, my input is 0. My output is 5. So 0, comma 5. My input is X. My output is Y. My ordered pair is X, comma Y. So evaluating functions in function notation. So we're going to evaluate each function in the given value. So f of x equals 2x minus 3. Find f of negative 3. So what we would do is we're saying, okay, this is my function, 2x minus 3. My input value is going to be negative 3. So I would write 2. We'll use pink this time. That doesn't change it enough. We'll go with blue. I'm going to substitute in negative 3. And then that minus 3 comes along at the end. Okay, so remember, this is substituted in right here, this x value. So 2 times negative 3, that is negative 6. Minus 3. Negative 6 minus 3 is negative 9. So When I input f of -3, my output is -9. Okay, you are just plugging in this value in for x. And then we have g of x right here. G of x equals 3 parenthesis 1 minus x. We have to find g of -2. So if I say g -2, that means everywhere I see an x, I'm going to go ahead and write in parentheses -2. All right, well, a negative and a negative makes a positive. So this becomes 3, 1 plus 2. 1 plus 2 is 3. 3 times 3 is 9. So g of -2 equals 9. Down here, we have h of x equals 3x squared minus 11. Find h of 3. And then we also have g of x equals 4 to the power of x. Find g of 2. So I'm not able to do it with my recording. But what you could do, and this will help you out on today's assignment, what you can do is you can type this into Desmos. And then you would type h of 3, and then it would also give you your answer. However, if we want to substitute in, so on today's assignment, I'm going to make a video today on how to do that for today's assignment to help you out. But how this would look is you would plug this in. 3 times 3, 3 squared right here, that's 9. Times 3 again, that's 27. Minus 11, 27 minus 11 is 16. Partner B, if you did this, you would say g of 2 equals 4 to the power of 2. If you type that into Desmos, 4 squared is 16 also, which is correct because both of these should match at 16. On the other side. So how function notation looks for other situations such as graphs and tables and verbal. So for the graph, when it says f of -1, remember that means -1 is your x value. Okay, so if I'm right here at -1, I look for where the graph ends up. And the graph right here, my y value right here, that's 0. So this is -1, 0. That one isn't a great example. Here's a better example. X is -3. So here's -3. I'm going to draw a line going up until I hit the graph, which is right here. That's 4. So when f is -3, my y value is 4. It's kind of like if I asked, hey, what class do you have first period? You would go to your schedule, you go to first period, and you'd be like, oh, my first period is art or whatever it is. Okay. That's what we're doing right here. Okay. You're searching up a time slot and you're trying to figure out where you're supposed to be. Same thing with the table. The table, it says my x value is 2. So here are my x values. I go over here to 2. And I'm like, okay, well, when x is 2, g of x is 4. And then here, when it's 5, I go over here to 5. My g of x value is 8. The more difficult situations is when it's a verbal situation. The function p of w equals 0.75w plus 5 represents the number of points a player has in a video game where W is the number of wins. If the player has 12 wins, how many points do they have? So, points, the number of wins counts to the number of points they have. And the function is 0.75 times W plus 5. So now I want to know if they have 5 wins, how many points do they have? So I'd say 0.75 times 5 plus 5. Well, 0.75. Oh, wait, I said 5. That's supposed to be 12. My bad. That's supposed to be 12. We're all humans. We make mistakes. Okay, 12 times 0.75, that's 9. Plus 5, that's 14. So when P is 12, when the player has 12 wins, they have 14 points. That's what that's saying. Okay? What would P of 5 equals 8.75 represent? Okay, so again, this is going back to this situation. So what we're saying here, what does 5 mean? 5 means 5 is the number of wins. And 8.75 is the number of points. Lastly, just out of curiosity, would this be a continuous or a discrete function? Because even though we can have decimal values for points, can we have decimal values for wins? Can you have half a win? No. So this one would be a discrete. These two, given that the function is defined by this would be discrete. This one, because they're connected, this one would be continuous. Just thought I'd throw that out there as well. Okay, these are your notes for evaluating functions and function notation.